Sergio will talk about Twilio approach to service-to-service authentication and authorization.
Okay.
I think we'll hear you here.
Yep. Can you hear me on the call just to make sure?
Yes.
I can hear you. Great. Okay, so hi everyone. I'm Sergio Velasquez from Twilio. I'm part of the platform infrastructure team at Twilio. So the agenda for today is a short introduction of me, the speaker. Then I'm going to talk about what was the problem we wanted to solve with SPIFFE Inspire, the technologies where we are using, right? Just to give context, then how we're managing authentication, authorization, and then the future work we are working in. So me, again, Sergio Velasquez. I'm from Bogota, Colombia. I'm traveling here for the conference, so it's pretty nice to meet everyone in person. Marcelo, yeah. And I like a few things I like volleyball, video games, anime, manga, if anyone can relate. Okay, let me talk a little bit about what was the problems we had that wanted to solve and that's why we end up using Inspire. So basically, while Twilio was growing, it started to face issues related mostly to multi-cloud deployments or multi-account in one cloud provider. So I didn't know this before joining Twilio, and for some of you, this might be obvious, but it was not for me. AWS accounts have a lot of hard limits on things like security groups, firewall rules, and those hard limits are something you don't face unless you are growing, right? You don't think about those having limits before you have a lot of deployments running, right? So for Twilio, that starts to be an issue. How can we manage multi-accounts, right? Even in one provider. And then how can we manage multi-account in different providers in terms of communication between services? So we had different services running in different accounts. How can we create security communication channels, right? Because before we were using security groups, firewall rules over security groups, but that's not possible in a multi-account environment. Or it is possible, but it's not easy to design, right? And then a second challenge was inter-region communication, right? So we have security groups, but that doesn't work well, or at least AWS doesn't have an explicit way of managing security groups between regions. And then over that, there are granular needs, we needed more security in that level 3 security for compliance things, right? So you can maybe share some kind of information between Europe and the US, but then you cannot share other type of information, right? So communication started to be an issue in different levels. And then we needed to solve this, right? We need to find somewhere, somehow, to trust communication, to be able to create channels and trust each service that was communicating to each other. So we end up using Spire to do that. And this is the basic technologies we use around it as of now. And then I'm going to talk later about the future technologies we're going to use. So what we decided to use Spire to try to solve these issues about multi-cloud, multi-account, multi-region communication. So basically we're using Spire with Envoy for authentication, and Envoy with OPA, Open Policy Agent, for authorization. And and basically most of our deployments right now are on EC2. And we built some stuff with, with a managed control plane for Spire in Go. And we have everything deployed with Terraform. And the CA we are using is AWS Certificate Manager, private PCA. Just to give an idea of the technologies we're using. So for authentication, how are we managing? We have a nested deployment. So we have one Spire server per environment and one SPIFFE server like child or downstream, upstream, like we call it downstream, but I just to make it clear, like one, like a SPIFFE server per environment, that is the main one, and then one per AWS region. So that is a child of that main one. And we have, like I'd say, ACM PCA is the CA. So we manage, we had a big discussion about which CA we were gonna use, because that was like a security concern. So we thought that it was important to really have like a secure way of using it. And PCA is a little bit expensive right now. That's why we have the nested deployment, right? Like that's one of the reasons we have the nested deployment and just one trust domain per environment, because we wanted to use PCA, but it's a little bit expensive. So that's what we end up with, right? Like one per environment we can trust and is secure. And then we have the nested deployment per region. And the identity is based on we have an internal system where people register their services. So we use that internal system like as a trust source to give the identity. So we check that internal system, and that's where we create the identities. From that internal system, we just collect that through the gRPC socket of the SPIFFE server, and we create the SPIFFE entries through that. So just to quickly explain all of that I mentioned. So we have a host, right? They will download the trust CA from S3. They will communicate with SPIFFE server. The SPIFFE server will like all this process. I don't need to explain it. Everyone of you is an expert. But basically we have like the SPIFFE server communicating with PCA. And then using let me move this here. So we have a concept of trust sources, and one of the resources we are using right now is the internal system that I was telling you, but we designed in a way that we could have multiple trust sources, right? And we are exploring other trust sources. So right now it works with our internal system, and that internal system creates the SPIFFE registries, like on the DB, and based on those registries, we can attest the workloads, the workload host, like the node itself and the workloads. And then we use like AWS metadata agent to trust the node. And an important thing to mention is, since we didn't find a way of like having a secure trusting mechanism inside each EC2, we are not doing that. We are just using we're just trusting the node, and we are using Envoy. So for each host, we are just giving the identity to Envoy, and everything inside the host just has one identity. And we did a lot of tries trying to find like what was the best way of like identifying a workload inside the node, but we just like didn't think there was a really secure way of doing that, so we are just not doing it. So anything inside the host has the same identity, and we are giving an identity to a host, and the one managing the identity is Envoy. So we use the service mesh we have that is using Envoy. So anyone that tries to communicate outside the host is just using the same identity. Like we could be running multiple things inside, but they have the same identity for the network, right? That's how we're doing it, the authentication part. And then for authorization, we are using these three things: Envoy, OPA, and SPIFFE. So Envoy uses the SPIFFE certs and makes decisions over, like each time that Envoy gets a petition, it passes the decision to OPA, and OPA uses SPIFFE IDs to make decisions. So we have OPA policies based on the SPIFFE IDs. So people can say like, allow this SPIFFE ID to do X. And OPA has like a language that is Rigo. So it's pretty like really extensive the things you can do. Like you can have like basic allowance, like just allow anything from this SPIFFE, or you could say allow gets, or allow a number of gets, a number of hosts, like, or if you have more things on the host, OPA could, I don't know, check other things in the host and make better decisions, better policies, more detailed, pretty granular. So we don't have like just basic authorization. It's more extensive. Like if any team needs to give like more details to authorization, they can. If they don't have to. They can use like basic authorization, right? Allow this BFAD. That was the idea. Like it could be pretty extensible if any team needs to do it. So basically, yeah, it looks like this. I took this from the SPIFFE documents, and we just have A and B, and we added like OPA there. And every time that A tries to communicate to B, Envoy does one, like communicates with OPA, and then OPA says like true or false, right? That's all that happens. So it's pretty fast. People were worried about like if this was gonna cause like create more latency, and it in our experience it doesn't. So we just added like OPA there. That's the thing. And then for future work, and now we are here in San Francisco, right? Like we have this idea of the impossible bridge between architectures. That's what we are trying to solve next. So we have this working in WAR architecture, Twilio basic architecture, but again, Twilio architecture right now is too tight together, and we are facing a lot of issues because everything is dependent on each other. So we have like a service discovery system that is totally dependent on the way we deploy things. So when Twilio makes a merger or an acquisition, our discovery system doesn't work there. And things like that. We have a lot of different things. Our deployment systems are created for one specific architecture. So changing all of that, it has been like, it's a challenge on Twilio right now. So we, on the authentication and authorization side, our challenge is how can we like create those bridges, right? On totally different architectures, kind of what the Unity thing was saying. Like they have, you know, Windows, Linux, bare metal, a lot of different deployments, and we are facing that. But then we decided, okay, let's not use Aspire everywhere, because maybe we have an acquisition and they don't have Aspire, right? And they don't want to, or we have another infrastructure we will, and Aspire is not, we are not able to use Aspire there. So what we're trying to do is just to have the idea we could have different things, and we will have everything should be like OIDC compliant, and we will use where we can, where we have the Aspire deployment, we will use the JOT tokens for the OIDC compliant communication. So between clusters, we are going to use, or that's our idea, we're going to use the JOT tokens that Aspire provides as OIDC compliant tokens. And then maybe inside of some of those clusters, there might be Aspire. That's how we are seeing this. And we are going to use Aspire where it's already deployed, right? So, but then basically how it would look like is if we have one service trying to talk to another service, we will have a JWT token. That this is basic, pretty basic, right? Like, and then use Aspire to solve that JWT token. And then when talking to a different cluster that will be managed by another thing like Istio, they will just have the OIDC federation to trust that token, right? And why? Because we explored a lot of different things before making this simple decision. This sounds like pretty simple, right? Like this, yeah, you do that, right? Like that's how you do it. But before doing this, we tried to do a lot of federation for the X509 certificates. And again, it was becoming too tight, right? Like everything depends on having federation over the root certificates. Everyone needed to have access to the root certificates. So, and then new mergers and new acquisitions have issues communicating to the federation point we had. So we just say like, let's not use that and let's just go back to the basic usage. And yeah, that's all. Thank you. Sorry, what? This one? Yeah. Okay.
Oh, thank you. Thank you, Sergio.
Sure.
So with mergers and acquisitions, I was curious with the different cloud providers like GCP or Azure, is also looking at Spire and GCP or Azure environment.
So maybe just to
You can just talk. It won't help. It's not
Oh.
going in there. It's like for our amplification. Yeah.
Oh, okay. I thought that it was going there. So we did think about it, but it was difficult. So I was like, it's different from what Unity was saying. We do have experts, like an expert team that is the team that I'm in on Spire. So it's not like everyone is comfortable with using something that they don't really know a lot. So we like convincing people in using our infrastructure, just yeah, let's install Spire there and use it. Like trust it. Like this is good. You can trust this. It's difficult, right? Like so we do have the idea of having a bundle that someone can just easily install everywhere if they want. And but that's the point, if they want to do it. So for mergers, and acquisitions, we were thinking of like if they want to install it, they can. But if not, we are gonna go with the OIDC compliant token thing. But that could be extensible, right? Like we could have the basic OIDC compliant, and then for some type of communications, we could have more detailed one like MTLS between everything. If both sides agree, that's the main thing.
So, a question regarding the hardware, we see you have difficulty in creating multiple identities to blind ADC to instead.
Right.